Imagine a financial firm deploys an AI assistant to answer policy questions. On day one, it gives a customer dangerously wrong advice because a single document chunk split the refund window in half. That's not a bug. It's a chunking failure. Today, you're going to master the psychology behind that mistake and learn to build retrieval systems that don't lie. Before we dive into the cognitive science, let's map out where we're going. After this deep dive, you'll walk away with 3 concrete skills. First, you'll use chunking to organize your IT certification study, so you learn faster and retain more. Second, you'll configure chunk size, overlap, and semantic splitting in a real Retrieval Augmented Generation, or RAG, pipeline. Third, you'll recognize and dodge the 3 most common chunking mistakes that make AI assistants hallucinate from your own documents. Chunking is the mental trick of grouping scattered information into meaningful wholes, just like letters into words. Now let's build on that. In 1956, psychologist George Miller published The Magical Number 7, plus or minus 2. He found the average person can hold about 7 chunks of information in working memory at once. Look at this chart. 5 random digits. Most people handle that fine. At 7, recall starts to get shaky. At 9, it often falls apart. But notice the last bar. 7 meaningful words. Each word is a chunk that packs multiple letters and memory span jumps back up. Chunking doesn't increase your storage. It packs more value into each slot. Let's connect the 2 ideas you've just learned. Which phone number is easier to remember? 5551 34567 or 555 123 4567? Take a moment to think about it. The answer is 555 123 4567 because your brain naturally groups the digits into meaningful chunks instead of treating them as one long sequence. Now here's the bigger question. Why does that help? Because working memory has limited capacity. Grouping related information into meaningful chunks lets you process more information without increasing the number of items your brain has to track. That's exactly the same principle we'll apply later when organizing documents for AI retrieval. Let's reinforce one more idea before moving on. According to George Miller's research, approximately how many chunks can most people actively hold in working memory? Now that you understand why chunking helps people learn, let's see how the brain organizes much larger ideas. Remember, the exact number of chunks a person can hold isn't the important takeaway. The key insight is that working memory is limited, so the brain constantly organizes information into larger, meaningful structures. That same principle appears throughout modern AI retrieval systems, where we organize related information into coherent chunks before searching it. Next, let's look at how the brain naturally builds those hierarchies. Neuropsychologist Carl Lashley argued that what looks like a flat sequence, say typing a sentence, is actually a nested hierarchy. At the top, you have a plan. Express an idea. Then sentences, words, keystrokes. It's not A, then B, then C. It's a Russian doll of subroutines. This diagram shows a commute. Your brain doesn't juggle 20 actions. It holds the high-level chunk commute and unfolds subchunks. Start the car, drive, park, each with its own micro-steps. That's how you execute complex tasks without your working memory blowing a fuse. In problem solving, you'll hear chunking up and chunking down. Chunking up means widening your view, moving from a single firewall rule on one server to your entire network design. Chunking down means narrowing, from the big picture architecture down to the exact port number. These moves are power tools. When you're stuck debugging, chunking up reveals the architecture you've been ignoring. When a manager wants a root cause, you chunk down to the precise setting. Now let's apply this directly to your career. The AWS Solutions Architect Associate exam covers a broad set of topics. Cramming each service in isolation is a guaranteed fail. Instead, chunk the material by the official exam domains. Design resilient architectures, design secure architectures, and so on. Under each domain, group the core services and patterns. That becomes your mental map. When a question hits on auto-scaling, you instantly pull from the resilient chunk, not a random fact. This structured chunking is what turns months of scattered study into a first-attempt pass. You're troubleshooting a deployment pipeline, and you've spent an hour investigating individual error codes without making progress. What's the best next step? Take a moment to think about it. The answer is to chunk up. Instead of focusing on one error message, step back and examine the larger deployment workflow. Source control, build, testing, deployment, configuration, and infrastructure. Looking at the broader system often reveals relationships that aren't visible when you're focused on individual details. Once you've identified the affected area, you can chunk back down to isolate the specific failure. Here's a trap I see juniors fall into constantly: trying to memorize 50 AWS CLI commands in one sitting, no groupings, no themes. That's not chunking. That's cramming. Cramming vanishes from your brain the moment you close the terminal. Real chunking means clustering commands by what they actually do, like putting all the networking commands together and learning them as a set. Here's the RAG pipeline stripped bare. A raw document hits the chunker first, then each chunk gets turned into an embedding, a numeric vector that captures the meaning of that chunk, and those vectors land in a database. The chunker is the single point of failure. If it slices a concept cleanly in half, the large language model never sees the full picture, no matter how good the retrieval is downstream. The next chart will show you how chunk size impacts retrieval accuracy. Imagine a financial firm's RAG assistant misinterpreted a key policy clause because the chunker split the phrase "not liable for" across two chunks, omitting the negation. The retrieval handed an incomplete statement to the LLM, which confidently gave the wrong answer. In a production environment, that kind of mistake can trigger regulatory fines, lost client trust, and costly remediation. This isn't a toy example. It happens when chunking is an afterthought. Most engineers get chunk size wrong, but picking the right number isn't just about copying a token count. In many English language documents, a rough estimate is about 4 characters per token, although the exact relationship varies depending on the tokenizer, language, and content. That means 500 tokens might correspond to roughly 2,000 characters for typical English text. But you should always measure using the tokenizer for your specific model. Recursive character text? Splitter's chunk size is typically measured in characters, though you should always verify the latest LangChain documentation. I usually begin around 600 characters as an initial baseline, then evaluate retrieval quality and adjust from there. The goal isn't finding a magic number. It's finding the chunk size that works best for your documents. Fixed-size chunking is the simplest approach. Split every n characters. The problem? It doesn't care about meaning. Look what happens when a crucial phrase like secure connection gets cut in half. The retriever might pull only the chunk ending with secure, missing that it's about a connection. Your LLM then answers incorrectly because it never saw the full context. This is the default trap that trips up teams new to RAG. The solution is semantic chunking, a technique that uses sentence embeddings and similarity thresholds to split only where meaning shifts. Let's break it down. Quick review. Why does semantic chunking usually outperform fixed-size chunking? Pause before answering. The answer is that semantic chunking respects meaning instead of arbitrary boundaries. Fixed-size chunking may split an important sentence or concept in half simply because it reaches a character limit. Semantic chunking looks for natural transitions, such as changes in topic, paragraph, or sentence, so related ideas stay together. Better context leads to better retrieval. You're building a RAG system over legal contracts containing long clauses with critical wording such as shall not be liable. Which chunking strategy should you choose? Take a moment to think about it. The answer is semantic chunking, because preserving the meaning of legal clauses is far more important than maintaining a fixed character count. Splitting a sentence in the wrong place can completely change its interpretation and cause the retrieval system to provide incorrect information. Overlap is the invisible glue. Here are two chunks with a modest overlap. Chunk 1 might contain John Smith, and Chunk 2 is the CEO. Without that shared segment, the retriever has no path from one piece to the other. Many practitioners use a modest overlap, often around 10 to 20% of chunk size, as a starting point, but you should test for your particular documents. The exact amount depends on your document structure, so experiment. Here are 3 chunking mistakes I've seen cost teams months of rework. Number 1. Making chunks excessively small. If you cut too aggressively, you shred the meaning. A chunk that reads, "Annual revenue grew," with no number is useless. 2. Skipping overlap. That clean cut right through the relationship between the board approved and a 15% dividend increase. 3. Tossing document structure in the trash. Headings and page numbers aren't optional. They're your retrieval GPS. Ignore them and you're searching a warehouse in the dark. Every chunk in a RAG pipeline can carry extra context, like where it came from in the original document, when you prepare it ahead of time. When you later retrieve a chunk, you can filter by that context. Need only chunks from a particular section? Add a condition that matches its source info. In healthcare, you might need to cite the exact page. Enriching chunks with origin data makes that possible. Imagine a legal team losing a multi-million-dollar contract because they couldn't prove which policy version the model used. Carrying that source context on every chunk would have prevented it. This conceptual chart illustrates how different chunking strategies can improve retrieval quality. Starting with naive, fixed-size chunking often produces inconsistent results because important context may be split apart. Adding overlap usually helps preserve relationships across chunk boundaries. Semantic chunking often provides another improvement because it keeps related ideas together instead of following arbitrary character limits. Finally, combining good chunking with metadata filtering can make retrieval reliable enough for many production workloads. The exact improvement depends entirely on your documents, queries, evaluation dataset, and retrieval pipeline. Rather than chasing universal numbers, compare different chunking strategies using representative questions from your own environment and measure which approach retrieves the most relevant information. How do you know whether your chunking strategy is actually working? Don't rely on intuition alone. Build a representative evaluation set with known correct answers, then compare different chunk sizes, overlap values, and semantic splitting strategies. The best chunking strategy isn't the one that sounds best. It's the one that consistently retrieves the right information for your users. Your RAG application keeps missing important information because related ideas are ending up in different chunks. Which two settings should you investigate first? Pause for a moment before answering. The answer is chunk size and overlap. If chunks are too small, important context gets separated. If there's little or no overlap, related concepts lose their connection across chunk boundaries. Those two settings are usually the first place to look before experimenting with more advanced retrieval strategies. Now that you've mastered the fundamentals of chunking, let's look at one of the techniques many production RAG systems use when basic chunking isn't enough. Instead of splitting a document only once, parent-child retrieval creates two versions. Small child chunks are optimized for accurate retrieval, while larger parent chunks preserve the surrounding context. When a user submits a question, the retriever searches the child chunks for precision, then returns the corresponding parent chunk, so the language model receives a much more complete explanation. Frameworks such as LangChain provide tools like Parent Document Retriever to manage this workflow automatically. It's an elegant way to improve retrieval quality without forcing you to choose between tiny chunks and large context windows. You've got all the theory. Here's your concrete 6-step checklist to hardwire chunking into your next enterprise RAG project. First, pick a production splitter. Recursive character text splitter in LangChain is the safe default. Second, dial in chunk size based on your content. Denser FAQ pages may need smaller chunks, while technical reports can be larger. Third, add overlap. Fourth, preserve metadata, headings, page numbers, source file names. Fifth, run retrieval test queries and check if relevant chunks surface. Sixth, iterate. Chunking is not a one-shot. This checklist is what separates a hack from a reliable AI system. You build a great chunking pipeline, launch the chatbot, and forget about it. 6 months later, an engineer updates the runbook. The bot still serves the old procedure, and an operator follows it, taking a production server offline. I've seen this happen. The fix: treat chunking as a living process. Set a scheduled job, like a cron job on Linux Unix, or a continuous integration (CI) pipeline that detects document changes, rechunks, and re-indexes your vector store. If you skip this, your RAG system becomes a museum of outdated knowledge. Let's get hands-on with a real code base. When you're building a developer portal, your docs are in Markdown with H2 headings. LangChain's Markdown header text splitter is built for this. It reads your Markdown files, splits on header lines, and automatically attaches the header text as metadata to each chunk. Watch the highlight. Here I configure the splitter to capture H2 and H3 headings. Then I set chunk size around 600 with overlap around 100 as a baseline. The result? Every chunk carries its section title, so later you can retrieve only authentication docs when a user asks about single sign-on, SSO. This is how you ship a portal that actually works. Your chunks don't live in a vacuum. After splitting, each one gets passed through an embedding model, such as one of OpenAI's text embedding variants, which turns that text into a dense vector of numbers. That vector, along with the original text, the chunk ID, and any metadata like the source page or section heading, all get stored together as a single record in a vector database like Chroma or Pinecone. Later, when a user asks a question, you embed that question the same way, and the vector DB searches for the nearest neighbors, meaning the most semantically similar chunks, pulling up everything you stored earlier. One row, one chunk, all context preserved. Quick review. When storing a chunk in a vector database, what information should be associated with it? take a moment before answering. At a minimum, you'll typically store the original chunk text, a unique identifier, and useful metadata such as the source document, section heading, or page number. The vector embedding is generated from the chunk and stored or referenced according to the capabilities of your chosen vector database and embedding workflow. Together, these pieces allow the retriever to locate relevant information while preserving enough context to produce trustworthy answers. Here's your next move. Open a Jupyter notebook. Import LangChain's recursive character text splitter. Configure chunk size, for example 1000, and overlap 200. Load a real document, say a PDF of your company's knowledge base. Run the splitter, then inspect the first chunk to see clean boundaries. Now experiment with different parameters and see how retrieval changes. This hands-on practice is how you lock in the skill. Throughout this deep dive, we've connected cognitive psychology to production AI. Let's lock in the 3 skills you walked away with. First, you learned to chunk your IT certification prep, like the AWS Solutions Architect, by exam domains, making study efficient and recall stronger. Second, you now know how to configure a RAG pipeline's chunk size, overlap, and go semantic to keep context intact. Third, you can now spot and dodge the 3 chunking traps, making chunks too small, forgetting overlap, and ignoring metadata. Those are the 3 pillars for reliable retrieval. Your assignment: get the AWS Well-Architected Framework whitepaper from AWS Documentation. Use LangChain's recursive character text splitter with try 1000 character chunks and 200 character overlap. Chunk the entire document, then create a vector store with Chroma. Find a way to retrieve a chunk that contains the phrase security pillar exactly. Post your notebook on GitHub and drop the link in the comments. That's how employers see you're serious. See you in the next one.